let's have a look at this question. This one says, O is the center of the circle. So I just want a yellow pen. If O is the center of the circle, I'm going to stop reading over there. If O is the center, folks, every theorem that you have learned in geometry needs to now kick in. Everything you learned about the center of the circle being important. Now let's quickly just run through a few of those. The first one is grade 9. If you have the center of the circle, there might be radii in that circle that are equal. If those radii form triangles, you're forming isosceles triangles. Okay? Another theorem that lies on the center, the line through the center of a circle to the center of a chord will be lying perpendicular to that chord. So that relies on the center. Then the line through the center of the circle subtends a right angle on the circumference. Then angle at center is twice angle on circumference. That's how you need to think about your geometry. You read the word and immediately you freeze and you think, okay, what does this tell me? Now let's go to the diagram. If O is the center of this circle, then OK is equal to OB is equal to ON. They are all radii. And more than that is that this angle here at K1 and K2 has just become equal to the angle at P because it lies opposite equal sides, okay, in that triangle that we've got over there. Okay, so with O being the center, so far I think that's what we can say. Excuse me. KOM bisects the chord LN. We stop. LN is a chord. It is bisected by the line MN. Folks, just excuse me. There's a frog in my throat. Don't know when that happened. Okay, so those two are equal. And remember what I said. There's a line that runs through the center of the circle to the center of the chord will be perpendicular to such a chord. And that is exactly what's happening at M1 and M2. And it's because the radius is bisecting the chord. So it does it at a right angle. Okay, let's see if there's anything else. Yes, indeed there is. Look at this. PN down here subtends the angle O2, but PN also subtends K1. K1 is 60 or 32, so O2 will be 64 degrees. The angle at the center is twice the angle on the circumference. Now, folks, I think that that is beautiful. We have just read one word. We've read center and bisect, and look at our diagram. We've got a lot of information on it. Let's read on. MNO is 26. So they've indicated it over here that that angle there is 26 degrees. Let me just do that with it, else I'm going to confuse it as these angles. Okay, K and P are points on the circle with NKP 32. NKP, we've already used NKP, it's over here, it was 32. And then they tell us that OP is drawn. So this line is drawn in. Okay, let's see what the first question is. The size of O2 for 2 marks. Determine giving reasons. And the second one is similar, but for 4 marks. So they want O2, and directly after that, they want O1. And we've got to give reasons for all the statements that we make. Okay, so let's go back to our diagram and see what happens at O2. Oh, we already know what happened at O2. It was double K1. So we can use that. The angle at the center was twice the angle on the circumference. So we start off, we say O2 is equal to K1. Is equal to twice K1 rather. The answer or the reason for that, the angle at the center is twice the angle on the circumference. And that's our reason for 2 marks. So O2 will be 64 degrees because K1 was given as 32. Quite straightforward. Okay, let's quickly revisit the diagram and look at where O1, what's happening at O1. O1 is this angle over here, this big thing here. What do I have? Well, I've got that these 3 angles form a straight angle, KOM, so they add up to 180. I need to look for something that can help me find O1. Now, O1 is also part of an isosceles triangle, but unfortunately, I do only have a part of this angle at K. I don't have the whole angle. Okay, so let's have a look what we are missing. We're clearly not seeing something. Now look at this. We haven't used the 26 yet. The 26 lies over here. It lies in a right-angled triangle. So the angle at O3 is going to be 50, what is it? That's 70, 60, it must all add up to 90. So that is 64 degrees, O3. And remember how we're going to argue it? It's for more marks. Where did this start? It started the moment M became 90 degrees. How did that become 90 degrees? Well, it was given that this line goes through the midpoint of the chord. So that's where our reasoning is going to start. We are going to say as an opening statement to finding O1 that first of all M1 is equal to M2 is equal to 90 degrees. Now remember your angle signs at the top. Why is that so? Well, the radius bisected the chord. Okay, and because the radius was bisecting the chord, that bisection happened at a right angle. Okay, and we also had from previously that angle O3 was equal to 64 degrees. That was just, oh no, we didn't have that. Remember O3 is, let's go back and check it. O3 is this angle over here. So it's a complementary angle. Those two add up to 90. So O3 is indeed 64. And the reason we're giving is complementary angle. Angles. It takes 2 angles to be complementary. Okay, now if that is 64, then what was O1? Well, remember, O1 plus O2 plus O3, all these angles were 180 degrees because it is a straight, we call that a straight angle. Okay, it lies on a line. They lie adjacent on the line, so it forms a straight angle. And all that's left for us is now to plug in our values. We have the fact that O1 is then, O1 is the one we're wanting, is equal to 180 degrees minus, now let's go for O2 again. O2 was 64 and that was both of them were 64. So we can just say minus twice 64. Okay, and that gives us 180 minus 128. It's 120 and the 2 times 4. And folks, that then gives us what? if I take 180 and I take 128 away from it, let me just make sure that I don't make a stupid mistake, it is 52 degrees. Okay, so we've got O2. O2 is 52 degrees. Nice. Let's see what they want us to find next. The next part of this question says, prove that with giving reasons that Kn bisects OKP. Now let's go back. Kn lies over there. We must show that it bisects angle OKP. So we need to show that this is 32 degrees, then the angle is bisected. Okay, now this is nice and interesting. I think we have, if we look very, very carefully here, we've got a 90-degree angle over there that we used to find the 64 with. So that became 64. These angles we still don't know, but if we can show that this full angle here is 64, then we've done our job. Okay, so what are we going to do? We're going to say, let this be a P. Okay? And we're going to say that these two 64s have got to give me P plus 32 plus this angle. So two of those P plus 32s, because those two angles are equal. Okay, so let's write the reasoning down. The angle at K is equal to the angle at P. That's where we're going to start. Let me just make space. The angle at K, now that's K1 plus K2, is equal to the angle at P. They are angles opposite equal sides. So we're going to say, let angle K2 be equal to P. Then the whole of K, so K1 plus K2, is equal to P plus 32 degrees. Okay, so now let's just draw that triangle that we had here, so we don't have to go back all the time. We had our radii, and we had this line which we want to prove. We've got that given us 32 degrees. We just made that P. We know this whole angle there is equal to the whole complete angle here, and there we had a 64 degrees and a 64 degrees. Now remember, this part here is a straight line. That's why we said this is a straight angle. So I can have these two are equal. I've already stated why that's the case. So this is a P plus 32. So two of those P plus 32 angles is equal to two of the 64s. And why is that so? It's the exterior angle of triangle. And remember, this was triangle POK. So of triangle POK. The exterior angle is equal to the sum of the interior opposite angles. Now look at how beautifully this goes. The 2's cancel. P will be 64 minus 32. And just throw that over, which leaves us with a 32 for P. And that in our diagram has the implication that that is 32 degrees. So definitely this line segment over here, which was, what is it, KM, or no, not KM, KN, it ended at N, bisected OKP. Okay, so just conclude that. Therefore, Kn does bisect. Sect has got one C, angle, what is it, OKP. And that's what they asked us to prove. So we use the grade 9 theorem. We use the fact that the exterior angle of a triangle equals the sum of the two interior opposite angles. Okay, let's see what is in store for us next. We're still busy with question 8 of the geometry paper. This one is a tad bit more interesting, but not necessarily more difficult. Okay, so let's read. In triangle ABC, this whole triangle over here, F and G are points on sides AB respectively. F and G are 2 points that lies on the sides AB and AC. Okay, nothing much said by telling us that. D is a point on GC. D is a point on GC. Now folks, that's important. GC is a line segment. Okay. So if they tell you that there's a point on a line segment, you can say, oh, why are they saying this? It's obvious. You cannot use exterior angles to figures unless you've written that something is straight. That's the relationship that must be in place. So look at this. For us to be able to work with this angle here as an exterior angle of sorts, this line had to be straight. That's why they told you that information. They are saying you're working on a straight line, hence there's exterior angles on that line. Okay, and they say it is in such a way that D1 is equal to angle B. Now immediately, I'm sure a lot of you at home are shouting out to me, open your eyes, Jacques, there's a cyclic quadrilateral, and you are 100% correct. Let's see why. Here's our straight line. There's the edge of the cyclic quad. The angle between there and the cyclic quad is equal to the interior opposite, or of the quadrilateral is equal to the interior opposite. So this will be a cyclic quad. Most probably that would be one of the first questions. Let's see what they ask us to do. They say that's 8.1.2, oh 8.2. Let me just go back a page and pull this down. Okay. The first question, this is 8.2. So they're asking me, my first question is to prove that AF is a tangent to the circle that passes through F, G, and D. Then, so there's two parts. They say AF is a tangent, then prove that the lines are parallel. So let's just go back one more time. If AF is a tangent to the circle that passes through the points F, G, and D. So let's just highlight those points. F, G, and D. This line is the tangent. The angle between the tangent and the supposed chord is equal to the angle in the alternate segment. So this one is also one of those. There's the supposed tangent. There's an invisible circle that runs through those 3 points. The angle between the tangent and the chord is equal to the angle in the alternate segment. Now immediately you can see, folks, with those two angles equal, these two lines just became parallel. And with them becoming parallel, there's other relationships in this diagram that we need to be aware of, and that we need to make note of when we get when we deduce things about a diagram. Okay, so I can say that this angle here is also equal to this angle here at the bottom, because they are correspondingly equal, just like these two were equal. And I think that is all we can say about that. So let's go and let's prove what they wanted us to prove. They said, if it's a tangent, then show that FG is parallel to BC. So first of all, my chord, this is the information that I have. just that I basically need to use. So I'm just going to draw the information for us that we need to use. Remember, this became a tangent. These two lines were parallel, and there was this line here with that angle there. Okay, that angle and this angle over here became equal because this became a tangent, and that will be AF. So we're going to use that to prove that these two lines are indeed parallel. So we're going to start by D1, which lies over here, which was given equal to B, which was over here. That's where this whole journey started. So we start off D1 is equal to angle B, and that was clearly given in the information. Then we can say that F1, this is angle F1. Angle F1 is equal to angle D. And why is that so? The tan-chord theorem, or the converse. You can say it isn't the converse because they gave it to you as a tangent. So it is the tan-chord theorem. Now look at this. Both of these two angles are equal to D1. So we've just shown that F1 is equal to angle B, that this angle is equal to that. Therefore, and why, if you want to, they both equal angle D1, if you wish to state that. Okay, so therefore it means that, what do we have there? We have the G, that FG is parallel to BC. And the reason would be that the corresponding angles are equal, and the lines being parallel is FG, that is parallel to BC. Okay, so that was our lovely 4 marks that we could get to over there. For another 4 marks now, we have a bit of more information that's going to make our life interesting. AF over FB. There's AF over FB. Now remember, the lines are parallel. So immediately, guys, your head goes to the proportionality theorem, which you use in grade 12. Okay, the first part up to now was just normal old geometry, pre-grade 12. So let's have a look. If AF to FB is 2 to 5, 2 to 5, these lines are parallel. So I'm going to say this here, let me use another color, I'm going to use the green, is 2m to 5m. Now you might be asking me, but why are you putting m's there with the 2's? And the reason for that is I'm turning the ratio into a length. So if m is 1, it's 2 and 5. If m is 2, it's 4 and 10. Okay, so it's working with the proportion or the ratio that they gave us there, and it turns it into a length. Okay, let's have a look. AC, they say, is 2x plus 6. Now, AC is that whole line from there to there is 2x minus 6. And then they tell us GC, which is this little component there, is x plus 9. Okay, so we've got to find, what are they asking us? They're asking us to find the value of x. Okay, so let's see what we can do. We can say that 7m, 2m plus 5m is 2x minus 6. So 7m is equal to 2x minus 6. But before we actually can say that, we've got to say why this is the case. So we're going to start off and we're going to say AF over FB is equal to AG over GC. That is the reason that over this is equal to AG over GC. And our reason there is the sides are in proportion. Okay, so now we're going to say, we're going to let AG equal, what was it, 2m, and GC equal 5m. And then we're going to bring that in to the picture. So we're going to say 7m is therefore equal to 2x minus 6, and that will be our first equation. Okay, we need another one. So let's see where there's more overlap. The next overlapping part is this x plus 10 over here, this, or x plus 9, which is this section there, which is equal to 5m. So x plus 9 over here, x plus 9 is equal to 5m. Now, folks, we're trying to find this x. Okay, so let's get m by itself. M will then be x plus 9 over 5. We don't like working with fractions. And here, from the yellow one, m is going to be 2x minus 6 over 7. And these two things, this is equation 1. This here is equation 2. And I'm going to use 1 equal to 2. Show your examiner what you're doing. Don't keep them guessing that you put this equation into that one. Label those equations and show us what you're doing. So 2x minus 6 over 7 is equal to x plus 9 over 5. Now, folks, that's a grade 8 equation. 10x minus 30 is equal to what? 7x plus 63. The x's collect to the left-hand side. This goes over 93. So x will definitely just be a beautiful 31. A lovely question, folks. It was filled with nice twists and things that you need to look for, relationships that you had to identify.